got a common factoring question. In fact, I shouldn't say common factoring because they don't actually tell us that. The question really just says factor. So if it just says factor. So we're looking at this relationship here. They haven't given us an equation. It's not equal to anything. They just want it to be viewed in a different manner. Now, you could argue this kind of looks like a factored form. But there's a lot of stuff going on. I'm going to try to relate it down to different terms. Okay. So think of this as one term times another term. I know it's a bracket and it has two terms in it, but really these are two terms um, multiplied by each other. And then we're going to subtract another term times another term. Do I have more colors? Yeah, I got yellow. Here we go. Okay. In reality, these are one term subtracted by another term. You can think of these as factors. So, for instance, there's a 9, there's a p, and then there's a set of brackets here. I'm going to give you an example of something that might look similar to this. Really, this is like the number, I need something bigger, 45. Subtract, what do we got here? 1, 2, and another one there. Let's get another value, 12. Here we go. Okay. This might be visually hard to relate to that, but all they've done is decompose each of the numbers into factors. So 45 actually has a couple different factors. I can split 45 up. So off the top of my head, I go 15 goes into 45. So I can write this as 15 times 3 minus, and 12's got a couple factors. I could write 4 and 3. Okay. So right away, I've got two numbers multiplied by each other, which is kind of what I have in my colors here. Here's a number multiplied by another number. And then here is another number multiplied by another number, and we're subtracting those values, okay? Now I could argue that I can break this down even more. 15 I can break into another set of numbers. That could be 5 and 3 and 3. So we have 3 numbers to subtract, and 4 can be broken into a 2 and a 2 and a 3. And then you get this relationship. We have 1, 2, looks like 3 different terms, okay? So in terms of numbers, that's what's really going on here. And common factor is just trying to find values that are common in both of the terms. So in our example, if we look through and we think of these as, just a pair of terms, do you see any common numbers? Is there a number that shows up in both of these?
For 3?
Yeah, 3 shows up in both. So in other words, I could technically factor out 3. I could bring 3 to the outside. Okay, so that's going to disappear from both of these because we're dividing by 3. That's one way to simplify. The 3's divide and make a 1. And then we're left with 5 times 3 minus 2 times 2. So there's another way to write it. But in all honesty, why on earth would I do that when I know these numbers? I would just do 45 subtract 12, okay? In this scenario, there's a lot of unknowns. So we're going to jump to the side, and we're going to do some factoring to help us sort it out. So I'm going to rewrite it here now that we've given it like an overview. And we'll say 9p times p plus 1 minus 20p times, run out of space, negative 1, negative p. Negative 1, negative p. Okay, there's a couple ways you can do this. I'm going to do your way first because I actually thought yours was a pretty ingenious way of doing it. You did the opposite of factoring first. You expanded and simplified. Okay, and how you did that is you distributed the factor on the outside to each of these terms. Okay, when you did that, you ended up with a 9p squared plus 9p, and you're at plus 20p plus 20p squared. You then collected like terms. We got these two together, and when you add those together, you get 29p squared. And you had these two like terms, 9p and 20p, so you got positive 29p. And then finally, you notice that, I can take some factors out. 29 comes out of both of these. So I'm definitely going to divide both by 29. So my very next line is going to be 29 and something in the brackets. And then what about variables? Well, you could take a p out of both of these, right? So 29p, because we divided both by 29p, that becomes the common factor. And then when we divide both, we end up with these 29's disappear. This becomes just 1p, and that becomes just the number 1. So you get 29p, p plus 1. All right, that's a way of doing it. But odd to usually expand first and then simplify. It might be a difficult thing to view. So another way we might be able to do something like this, I'm going to rewrite it again, We have our 9p, p plus 1, minus 20p, negative 1, negative p. Okay, another way I might look at this is, I got these two sets of brackets. Think of them as a single term, even though there's a few terms in the bracket. This is a number. And I quickly notice, hey, there's a p here, there's a p here, there's a 1 here, there's a 1 here. The only thing is they're opposites. Well, I can common factor out of this bracket negative 1. And when I do that, the idea is I'm pulling negative 1 from both numbers, and it's going to become the common factor in front. Well, I already have something that's being multiplied. Factors just mean multiplication. So the first thing, I'm not going to change anything. 9p, p plus 1. The second one, though, I have one of my factors, which is 20p. Remember, we broke it into like a 4 and a 2. This is just a factor. And we're common factoring out negative 1, so it's another factor. We're going to multiply by it. So I've taken negative 1 out. When I do that, what's left inside my brackets? Well, negative 1 divide negative 1 is 1. Negative p divide negative 1 is positive p. With a little bit of rearranging, because this is addition, I'm going to subtract that and rearrange it. I can just write that as p plus 1. P plus 1. Now, I have two terms that are the same. This means I can common factor out the bracket. Sometimes a hard thing to see. So what you can do in a case like this is you can use a let statement. I'm going to say, well, what if I just said let p plus 1, because those are both the same, equal x. When I go to rewrite this, I would have 9p x minus 20, okay, I'll write it that way. 20p minus 1, and then x. Okay, so I have an x in both. I know I can take an x out if I'm going to common factor. So right off the bat, we can divide by x. Can we divide by anything else? See any other terms that appear in both? P. I can take a p out. I can take a p out of both of these. I think that's about it, right? Everything else looks like it's going to stay. 9 and 20 I don't have a common factor for. This is a negative 1. I'm going to keep it and we can deal with it after. But let's common factor out p at x. When I do that, this all disappears and we have a 9. Okay. And here we have negative 20. P's disappears, x's disappears, times negative 1. Do you know what negative 20 times negative 1 is?
20.
20. Take a look at that. Is that something we can simplify?
Yeah.
Yeah, I can simplify that. What would that be?
Px times 29.
Times 29. Okay, so px 29. How do we normally write a number like that?
29p.
Yeah, we usually write the numeric value we know in front of variables, right? So I could say that's actually equal to 29p at x. Okay, that's done. The only thing is, was there an x in the original question?
No, it's p plus 1.
Yeah, so let's substitute back in. We'll write that same let statement to let our reader know that, oh, I'm subbing back in p plus 1 is equal to x. So when we do that, we end up with 29p, and we substitute in for x our p plus 1, which is our factored 4. Now, I will tell you that this last version, you may go, why on earth did I do that? That looks like it's the longest. In terms of mental math, this is something I would have saw instantly. I can take my negative out, and then I can just common factor out this p plus 1. See how it came out as a common factor here? Yeah. I could have written in the front, and what would have been left with was 9p minus 20. I knew I could common factor the p out. 9 minus 20 gives us, 9 plus 20 gives us our 29. So mentally, this is something, though it looks like a very long algorithm, actually easiest for someone like me to see. This is one I'd probably have to write out. I wouldn't be able to hold all those different terms in my head and then common factor them all out. And then this is just kind of an example of what a common factor looks like. Does that idea kind of make sense there?
Yeah.
Yeah.